Today's session is about derivatives of inverse trigonometric functions. Let's recap some formulas. Differentiation of sine inverse is 1 by under the root 1 minus x square. Differentiation of cos inverse is minus 1 by under the root 1 minus x square. Differentiation of tan inverse is 1 by 1 plus x square. Differentiation of cot inverse is minus 1 by 1 plus x square. Differentiation of secant inverse is 1 by modulus of x times under the root x square minus 1. Differentiation of cosecant inverse is minus 1 by modulus of x times under the root x square minus 1. Example: y is equal to 2 cos z plus 6 cos inverse z. Here, as two functions are added, sum difference rule is used. Dy by dx is equal to d of 2 cos z plus 6 cos inverse z by dx is equal to differentiation of 2 cos plus differentiation of 6 cos inverse z is equal to differentiation of 2 cos is minus 2 sin z plus differentiation of 6 cos inverse z. 6 is constant, hence taken out, and differentiation of cos inverse z is 1 by under the root 1 minus z square is equal to minus 2 sin z minus 6 times under the root 1 minus square. Example: g of t is equal to cosec inverse t minus 4 cot inverse t. Dy by dx is equal to d of cosec inverse t minus 4 cot inverse t by dx. Differentiation of cosec inverse t is minus 1 by modulus under the root square minus 1 minus differentiation of 4 cot inverse t is 4 times minus 1 by 1 plus t square is equal to minus 1 by modulus of times under the root square minus 1 plus 4 by 1 plus t square. Example: y is equal to x tan inverse x. Here, we see product of two functions. Hence, product rule is used. Formula is this. Now in this example, dy by dx is equal to differentiation of x, tan inverse x. Dy by dx is equal to x multiplied by differentiation of tan inverse x plus tan inverse x multiplied by differentiation of x is equal to x multiplied by differentiation of tan inverse x is 1 by 1 plus x plus tan inverse x multiplied by differentiation of x is 1 is equal to x by 1 plus x square plus tan inverse x. Example: y is equal to sec inverse x. Cosec inverse x. Here, we see product of two functions. Hence, product rule is used. Formula is this. Now in this example, dy by dx is equal to differentiation of sec inverse, cosec inverse. Dy by dx is equal to d of sec inverse x, cosec inverse x by dx is equal to sec inverse x times differentiation of cosec inverse x plus cosec inverse x times differentiation of sec inverse x is equal to sec inverse x times differentiation of cosec inverse x is minus 1 divided by modulus x times under the root x square minus 1 plus cosec inverse x times differentiation of sec inverse x, which is 1 divided by modulus x times under the root x square minus 1, is equal to 1 divided by modulus x times under the root x square minus 1 times minus sec inverse x plus cosec inverse x, is equal to 1 divided by modulus x times under the root x square minus 1 times cosec inverse x minus sec inverse x. Example: h of x is equal to sin inverse by 1 plus x. Here we see division of two functions, hence quotient rule. This is the formula. H dash x is equal to differentiation of sin inverse x by 1 plus x. Applying formula. H dash x is equal to 1 plus x times differentiation of sin inverse x minus sin inverse x times differentiation of 1 plus x whole divided by 1 plus x whole square is equal to 1 plus x times differentiation of sin inverse x is 1 divided by under the root 1 minus x minus sin inverse x times differentiation of 1 plus x, which is 1, whole divided by 1 plus x whole square. is equal to 1 plus x times 1 divided by under the root 1 minus x minus sin inverse x times 1 whole divided by 1 plus x whole square is equal to 1 plus x divided by under the root 1 minus x minus sin inverse x whole divided by 1 plus x whole square is equal to 1 plus x minus sin inverse x times under the root 1 minus x square whole divided by under the root 1 minus x square times 1 plus x whole square. Example: y is equal to sin inverse to x cube. Here we see function of function, that is sin inverse of 2x cube. Hence chain rule, formula is this. In chain rule first we differentiate the outer function keeping inner function as such and then differentiate the inner function. Here, dy by dx is equal to differentiation of sin inverse of 2x cube is equal to differentiation of outer function sin inverse keeping the inner function to x cube as such multiplied by the differentiation of inner function to x cube is equal to differentiation of outer function sin inverse is 1 by under the root 1 minus 2x cube whole square times the differentiation of inner function to x cube, which is 6x square, is equal to 1 by under the root 1 minus 4x to the power 6 times 6x square is equal to 6x square divided by under the root 1 minus 4x to the power 6. Example: y is equal to sec inverse cos x. Here we see function of function, that is sec inverse of cos x. Hence chain rule, formula is this. In chain rule first we differentiate the outer function keeping inner function as such and then differentiate the inner function. Here, dy dx is equal to d sec inverse cos x by dx is equal to differentiation of sec inverse keeping cos x as such multiplied by differentiation of cos x is equal to differentiation of sec inverse keeping cos x as such will be 1 divided by modulus of cos x times under the root cos x square minus 1 whole multiplied by differentiation of cos x, which is minus sin x, is equal to minus sin x divided by modulus of cos x times under the root cos x square minus 1. Example: y is equal to under the root inverse, it can be written as cos inverse x to the power 1 by 2. Y is equal to inverse to the power 1 by 2. Here, chain rule, outer function is power 1 by 2. Cos inverse x is considered as inner function. Dy by dx is equal to d of inverse to the power 1 by 2 by dx. Dy by dx is equal to d of inverse to the power minus 1 by 2 by dx is equal to differentiation of power function 1 by 2, keeping the inner function cos inverse as such, multiplied by differentiation of inner functions cos inverse x, is equal to differentiation of power function 1 by 2, keeping the inner function cos inverse as such, is 1 by 2 times inverse to the power 1 by 2 minus 1 is minus 1 by 2, multiplied by differentiation of inner functions cos inverse x, which is minus 1 by under the root 1 minus x square. Rearranging it can be written as is equal to minus 1 by under the root 1 minus x square times cos inverse x to the power 1 by 2 is equal to minus 1 by under the root 1 minus x square times under the root cos inverse x